Okay, 3.2C College Algebra. We are going to continue on with this fun stuff. I mean, I hope it's not too terribly disgusting to do these. I think they're kind of fun. I mean, they're not like really hard, and it's kind of a puzzle to fit together, and hopefully I'm explaining it in a way that makes it at least somewhat understandable. It really makes it hard to talk and write numbers down at the same time. All right, so that's what they give you for example 3. We have not learned how to factor that yet, so the book goes ahead and factors it for you, which makes things very good. All right, now notice this has a multiplicity. Negative 1 has a multiplicity of 1. 4 has a multiplicity of 1. And 2, the answer to make that 0, has a multiplicity of 2. Okay, just kind of throwing that out there. All right, if you look again on page 258, you can see the leading term has a 1 here. It's positive, and that number is even. So you're going to get a graph that's going to look like this. And again, for this problem, we're finding out what's going on in there. Okay, so to find the zeros, we've got those. Our zeros are going to be then negative 1, 2, and again, that has a multiplicity of 2, and 4. So my x-intercepts are negative 1, 0, 2, 0, and 4, 0. Okay, that's where it crosses. Crosses at 3 different places, and that tells you, all right, so we got 4, and this says there's 4 answers. Well, we do. We have 4 answers. We have 1 answer here, 2 answers here because it's squared, so because it says multiplicity of 2, and then 1 here. And one of the things that you'll notice, if you add up your multiplicities, 1 plus 2 plus 1, you're going to get this number. This just says that you get the same answer twice. So when you get the same answer twice, when you put them down on where it crosses, you end up crossing at 3 places instead of 4. So hopefully that makes sense to you and you're kind of following. Okay, I see how that happens. All right, so when we divide these into intervals, our intervals are always going to be one more than our our zeros. Yeah, okay, say always. I guess I shouldn't say that unless I know for absolute sure, but usually. So there's interval 1, okay, that takes us from here this way. Then we've got an interval of negative 1 to 2, which is our next interval. And then remember, this 2 is last, so it becomes first here. And I shouldn't put a 0 there. That needs to be a 4. Between 2 and 4. And then from 4 we go 4 to positive infinity. Okay, so we have 3 different places where it crosses. Okay, and we have 4 intervals. Alright, so hopefully that's catching on, because I know for most of you this is brand new. Alright, so let's go ahead and find some x's to stick in and find out what our y values are, our g of x, based on those. So if we have a number between negative infinity and negative 1, I don't know why in the world the book put negative 1.25 as one of the points it's using, because I can go all the way to negative infinity. So I'm going to use negative 2 here, and here I'm going to use 0, and here I'm going to use 3, and here I'm going to put a 5 in. Alright, let's see what happens here. So I've got to put negative 2 in this whole stinking thing, 0 in the whole thing, 3 in the whole thing, and 5 in the whole thing. Well, I know when I put 0 in there, all these cancel out and I get negative 16. And I know when I put 3 in there, I get negative 4. But I'm going to shut this off and figure out what happens when I put negative 2 and 5 in there, and I'll put those answers there when I start it back up. Okay, so those are the numbers I get when I plugged in negative 2 and when I plugged in 5. So again, I can look at this as I was solving it, and it was actually 625 plus 875 plus 300 plus 4. I didn't have to add all those together and get 1804, because I knew the answer is going to be positive, and the same here. So I just put them down there just to show you how big they were. So obviously we're not going to use these to graph, but it did tell me that they're both positive on those ends. So that was important. All right, so again we find the y-intercept. So let's go ahead and do that. So y-intercept means for g of x is 0. We get x to the fourth, so 0 to the fourth minus 7 times 0 to the third, plus 12 times 0, plus 4 times 0, minus 16. So there is my y-intercept. So you notice when we were doing y-intercepts, I think in the last chapter, maybe the last section, we talked about this number here being where it crosses the y-axis. And it does that because all of these x values, when they're 0, all of this goes to 0. All this cancels out. So our answer is actually going to be this number right here. 0, negative 16 is where it will end up crossing the y-axis. Alright, so let's see if we can make kind of a little graph here. And it's going to cross at, what did we say, negative 1, at 2, and at 4. Okay, it's going to look like that. So we're positive over here. Let me get a different color. We're positive here, we're negative here, and positive over there. Okay, so what goes on here? See how this is negative and negative? This is like, wait a minute, this is kind of weird. How can it both be negative and cross here? If we're negative here and we cross here, then we're going to be positive, right? Unless we come up here and touch this tangent and then come back down. So it doesn't cross, it's just tangent. So just some things to consider when you're doing these. So what this is going to do, and let me get green here. This is going to come down here, cross at negative 16, and then it's going to come back up to 2, 0, touch that point, not cross it, come back down, and at a certain point down here it's going to cross and then go back up there. So we've got a crossing at the y-intercept, which we said was negative 16, so that's negative 16. Then it comes up, and because these are both negative, we know it doesn't cross the x-axis, because the minute it crosses the x-axis, it becomes a positive number, and this says it's negative. So that's what tells me that it just touches it, comes back down, and then goes back up. Now, what you're going to do is you're going to put some numbers. Well, you don't really have to put any numbers in here because you kind of get an idea of what it's doing. But anyway, normally you put numbers from here to here in to find out what it's doing in here. Okay? So you put a bunch of numbers in here and you're going to get, and it takes time to put these numbers in here to find these points to see what it's doing along between these two intervals there. So anyway, that's basically what that one looks like. So let's go into the intermediate value theorem, and this is just one of those ways to give you some idea about what goes on with the graph. There's not really a huge formula or a huge mess to kind of figure out. It just kind of gives you some clues as far as what goes on in the graph. So for instance, let me put this on the board. Alright, so sometimes the book makes it real hard to figure out what's going on when they put all these letters in there. So let's go ahead and get rid of the letters, and let's just put this point being 3, 4. And let's put this point as being 6, negative 3. Okay, it doesn't really matter which one it is. Alright, so one of the key things is the y value here is positive. It's above. The y value here is negative. What the interim value theory it says is that when we have a y value that has opposite signs, so this number here, or this coordinate here, has a y value of a plus, and this one has a y value of a negative. Or if this were a negative and the other one were a plus, okay, if it went that way, it doesn't really matter. As long as the y values are opposite signs, then we know, beyond a shadow of a doubt, that the graph somewhere between this point and this point crosses the x-axis. It has to, because this one is in positive territory, and this point is in negative territory because of the negative y. So that means in order to get from positive to negative, it has to cross the x-axis. There is a 0 between there. There is an answer between there. I guess that's the key here. If we have 2 points and it crosses the x-axis, then I know I have at least one answer between here. Okay? All right, the other thing is, if these numbers are not opposite in sign, it doesn't mean that it doesn't cross the x-axis between there. It just means that we can't determine that from the intermediate value theory. We can't just look at this. If this were a 4 and this were a positive 3, let's put a positive 3 here, it doesn't necessarily mean that this doesn't cross, because what could happen? It could go, okay, so there's my 6, 3. So did it cross? Yeah, it crossed twice between here and here. It just went down and came back up. Okay, so if the signs are positive, we can't say no, it does not cross the x-axis. It just means we can't tell. So if the y values are opposite in sign, then we know for a fact that it crosses at least once. Okay, it crosses the x-axis, and the number between here and here where it crosses is the answer. All right, taking us to example 4, and all they're doing there is giving some examples and asking you to determine if there's a real 0 between the two. So I'm just going to do this real fast. So all it's asking you to do here for part A is take -4 and put in here to find the y value, and you find out when you put -4 in, you get -24. When you put -2 in, you get a positive 8. So I know that there is an answer, there is a 0 somewhere between these two that crosses the x-axis, somewhere between -4 and -24 and -2 and 8. Whoops, I'm trying to write too fast. So there is an answer somewhere between these 2 points. Okay, when you graph them, -4, -24, -2, 8. So somewhere between here, we're going to cross the x-axis. Don't know where. All right, when you look at the B portion, they give you another equation, and what it says is it equals x cubed plus x squared minus 6x, where A equals -1 and B equals 3. I'm trying to rush through here before I lose time here. So I'm going to put -1 in to this equation. When I put -1 in, it kicks out a 6. And when I put a 3 in, it kicks out an 18. So what that tells me is they're both positive, so I can't determine using the intermediate value theory if there is an answer between these 2 points. Doesn't mean there's not, it just means I can't make that determination. And that's all that shows, okay? And that's all there is to the intermediate value theorem, and that's all there is to section 3.2.